Hello, my name is Muzinga.
I'm Geraldo.
I'm Arya.
We're students from BCIT Mechatronics and Robotic Project. Our team name is MADA, and our project name is the Mule, which is an autonomous mobile cart designed to help people with mobility challenges. And I'm going to have Geraldo explain the subsystems that make our cart work.
The MSP 430 as our main microcontroller to move and use the desk the way we want to. And we'll be using three main sensors: the vision system, ESP32, and the ultrasonic sensors. And we will combine all of them using sensor fusion inside the microcontroller MSP 430. The vision system is for color tracking. Is right here in the front. And then we have the ultrasonic sensors, which are on the bottom. These here are mainly used for obstacle avoidance, so we can avoid obstacles and navigate the way we want to go. And finally, we have the ESP32, which are distance navigators. Or right here on the front, as you see, we do have one. Sadly, two of ours are missing as they've gone stolen from an Amazon thief or package thief. So we are delayed on those, which we will be adding throughout the final presentation around April 28, I believe. The main sensors which we'll be using to make it navigate and follow user and help them throughout their day. Next, I'll bring Geraldo, our ESP32 master. He's very good at it, and he'll explain mainly how we'll be using these ones, the ultra widebands, to navigate and follow a person very accurately and precisely, so it can help them with their daily tasks.
So I'll be explaining the logic behind how the robot is going to track the person or the user. So the user is going to have an ESP32 module, and then on the robot itself there will be three. One on the middle, one on the side, and then another one on the other side. They will create an imaginary triangle, and then based on that triangle, we'll get three types of distances. So we'll have the distance between the first slave and then the second slave. So based on this triangle, we can create a logic where if D1 is not equal to D2, the robot will reorient until both distances are equal. And then the robot will make a decision, either it will move back or forward based on the distance between the master, which is in the middle of these two.
Hey, it's Muzinga again. I'm back and I'm gonna demo for you guys how the ultrasonic sensors work. And basically the ultrasonic sensors is our main sensor for obstacle avoidance, because as Geraldo explained to you guys, we have the ESP32 UWB that act as the tracker for tracking the person we're following. We have the vision that supplements that, but we see that it's kind of a little bit unreliable. So these paired together work the best, and that's for tracking. This ultrasonic sensor is for avoiding obstacles, and I'm gonna demo for you guys a little bit of how that works. So we have these sensors. We have two models. One is an SRF05, and around the perimeter we have SRF04s. And how those behave is we send a signal, we send a trigger. The trigger signal sends an ultrasonic wave that goes and bounces back, and we measure that distance, the time it takes for the echo to come back, and we divide it by 2, and using the speed of sound that we already know, we can find the distance between the object and the robot, and we set a threshold of 20 centimeters, and we feel like that's enough, a safe enough threshold that will indicate that the obstacle is way too close. And then we have that send a signal to the MSP, which is the motor controller. The motor controller then sends a signal to the H bridges to move the wheels and the conduit wheels away or towards a different direction to avoid said obstacle. We have the mechanical wheels here. We have an algorithm that determines what direction to take, because this cannot, there's no steering of any sort. So we have a series of movements where two of the front wheels will move forward or backwards. We either move forward, back, left, or right. And I'm gonna show you guys a short demo really fast. This one. You see, like right there, I'm coming directly at the front. So then the robot goes backwards. If you see the movement of the wheels, it goes backwards. And then if I were to come on the left or the right, you can see that there is a different sequence of wheel rotation that then should theoretically move the boat left or right. I'm gonna put it down to the floor so that we can see that much better. I'm gonna turn this off. Okay, and coming from the back, it should move forward. Coming from the front, it should move backwards. And then if I were to come to the side, that should... We're having a bit of technical difficulties there, but it should start. Hi, Muzinga. Thank you very much, Geraldo. Thank you very much, Arya. And now we're gonna demo how this cart is supposed to autonomously follow a user around. And then it's in this demo, it has to show you the capabilities of locking. We're currently using a color sensor, which we calibrated to track the color red for now. And also, we're gonna demonstrate how the ultrasonic sensors senses a distance threshold, and then it should move away to avoid colliding with an object. So now I'm gonna turn it on, and it should be able to start right away. First, we're gonna have it not see any color red, and in that case, it shouldn't follow anything. But once we have the color red in the camera's frame, it should be able to lock it to the color red and follow it back, matching the speed as well. So here we go. It is on right now, and nothing happens. And once I put red, it should follow. And you can see how fast the reaction is, and you can see how it avoids the obstacles. And we can have it follow red all the way and avoid obstacles as well. Thank you guys. That was us, Mata from BCIT Mechatronics and Robotics. And I hope the demo was very satisfying for you guys. And thank you guys for considering us for your competition. And we understand that currently the codes are a bit choppy and the parts are a bit of a mess, but these are going to be replaced with PCBs, so that's going to make that much cleaner. We're going to have a better battery pack so that it can run the motors more efficiently, and we're going to implement a LiDAR sensor so that our sensor fusion can we're going to add a LiDAR for obstacle avoidance so that our sensor fusion will be seamless. We're going to implement some PIDs to make sure that the movements are a bit smoother so we can achieve cleaner motion profiles. And yes, thank you guys very much, and we hope to see you guys very soon.
Thanks.
We are Mata. You have to say we are Mata.